Co-prime numbers. Numbers having no common factors other than 1. That is, if HCF of two numbers is 1, then they are co-prime numbers. For example, 4 and 25, 12 and 17, 6 and 35. These are pairs of co-prime numbers. They need not be prime. The sum or difference of a rational and an irrational number is irrational. Example, 7 plus root 2, negative 5 plus root 3, 15 minus 2 root 7 are irrational. The product and quotient of a non-zero rational and irrational number is irrational. For example, 5 root 2, 15 by root 3, negative root 5 by 2 are irrational. Next we are going to study one important theorem, which is theorem, let P be a prime number if P divides A square, then P divides A, where A is a positive integer. For example, if 2 divides A square, then 2 divides A also. Second example, if 5 divides 100, that means 10 square, then 5 divides 10. Next we are going to prove root 2 is an irrational number. That's an important theorem. The proof we are doing by contradiction method. Okay. Theorem, root 2 is irrational. The proof we are doing, let root 2 be a rational number. Rational number means what? It is of the form P by Q or A by B. So we are selecting root 2 equal to A by B, where A and B are co-prime numbers and B not equal to 0. The numerator and denominator are integers, and also these two numbers are not having any common factor other than 1. That is, A and B are co-prime. They have no common factors other than 1. Now the next step, just to do cross multiplication. That is B into root 2. That is, the next step is root 2b equal to A. Next is squaring both sides. So we are squaring the left side and right side. LHS we are getting 2b square and RHS we are getting A square. So the next step is 2b square equal to A square. So we can write that 2 divides A square, because A square is 2 into B square. So 2 is a factor of A square. That is 2 divides A square. By the previous theorem we can say that 2 divides A. That is one condition we are selecting number 1. Then next step we are selecting A equal to 2C. A equal to 2C. C any integer. Then next step is squaring. A square equal to 2C whole square. 2C whole square means 2 square into C square. That is, we are getting 4C square. Now A square, instead of that we can use that idea 2B square. So 2B square equal to 4C square. Next step we can cancel that common factor 2. So it is 2 we are cancelling, and the next step is B square equal to 2C square. So in this step we can say that 2 divides B square, because B square equal to 2 into C square. Now by applying the previous theorem we can say 2 divides B. That is the second condition, equation number 2. Not equation, it is a condition number 2. Okay. Now from 1 and 2, from these two conditions what we got? 2 is a common factor of A and B. 2 is a common factor of A and B means it is a contradiction. It is the opposite condition we got, because we have selected A and B as co-prime numbers. Co-prime numbers means they have no common factors, but we got 2 as a common factor. And because of this contradiction, we can say that our assumption is wrong. Our assumption means what? Root 2 is a rational number. That is wrong. So, we are getting root 2 is an irrational number. And the same method we can apply for finding or proving root 3 is irrational. And the next question is prove that root 3 is irrational. So again the same method we are starting. Let root 3 be a rational number. Then we can write root 3 equal to a by b, where a and b are co-prime numbers and b not equal to 0. Then next step, cross multiplication. So we are getting root 3b equal to a. Then next step, squaring both sides. So we are getting 3b square equal to a square. The next step you can write 3 divides a square. And by applying the theorem we can say 3 divides a. It is the first condition we are marking as number 1. Then next step we are selecting a equal to 3c. And again the same squaring both sides. A square equal to 3c whole square, which is 9c square. Next, a square, instead of a square we are writing 3b square. So 3b square equal to 9c square. Then cancelling the common factor 3. So we got b square equal to 3c square. In this step we can write 3 divides b square. So we can say 3 divides b. That's the second condition. And from the first and second conditions we can say that 3 is a common factor of a and b, which is a contradiction to our assumption that a and b are co-prime numbers. Therefore, we can say that our assumption is wrong. Which is our assumption? Root 3 is a rational number, which is wrong. That is, root 3 is an irrational number. Okay,